Okay, Assalamualaikum and good day everyone. So let's proceed with part 2. We continue with 2.2 Techniques of Differentiation. So under this topic we have product rule. Okay, let us scroll for a while. So we have product rule and we have quotient rule. That is the second technique. The third technique is chain rule. Okay, followed by technique number 4, which is implicit differentiation, and then we have fifth method, which is parametric differentiation. Okay, and yeah, altogether there are 5 techniques of differentiation before we go to the transcendental functions, which are trigonometric and hyperbolic, as well as logarithmic. But that one would be your next week lecture. So for this week we're only focusing on first rule, okay, first rule formula or first rule differentiation, and techniques of differentiation. Okay, all right, so let's proceed with product rule. So product rule, I bet this is the easiest technique. Okay, you have learned this before during your SPM and STPM, and also during your diploma in Polytechnic. So basically, product rule is we apply it to find the derivative of the product of two functions. So if you have the first function is fx, the second function is gx, so fx times gx, so we can apply the product rule for this kind of function. In other words, we can also write it down. So fx is y, as this small fx here, we assume it as u, function u, times gx is function v. So from this, okay, we can actually simplify the formula. So the original one, okay, the basic formula here is dy over dx, okay, equals to u dv over dx plus v du over dx. Okay, so you can also write down as, so dy over dx, okay, this dy over dx we can also write it down as y prime equals to u, okay, dv over dx we can write it down as v prime plus v, right. The second term is du over dx, we can write down as u prime. So what is v prime, u prime, and so on? So let's go to some example. Okay, right. So example 2.2, differentiate y with respect to x if y is equals to 4x squared plus 2 times 3x cubed minus 1. So this is a simple one, quite a simple one. Okay, you don't need to apply chain rule for this, okay, because this is only consists of two different functions. So this is the fx, this is the gx functions, or in other words you can write down as y equals to u times v. Alright, so what you need to do is that you need to find one by one. So we define the u equals to 4x squared plus 2, alright, and the v we define it as 3x cubed minus 1. Now we need to find the u prime and the v prime. So what does it mean by u prime and v prime? It means that you need to find the differentiation for the u function, and for the v prime you need to find or differentiate the v function. Okay, so when we do this, so 4 times 2 is 8x, right? So plus 2 is a constant. If you differentiate a constant, you'll get 0. Okay, that's 0 over there. And then we proceed to v prime here. So v prime is 3 times 3, okay, which is 9. Okay, 9x. So the power will decrease by 1. So 3 minus 1 is 2. Right, and minus 1, if you differentiate it, you will get 0. So basically u prime is 8x and v prime is 9x squared. Okay, so just if you I don't know, if you never heard about differentiation, okay, that's okay, but it's very simple for the basic one. So for example, if you have this kind of function 2x squared, we did this one before in first rule, but never mind. If you want to find the differentiation for this function, which is y prime, what you need to do is that you need to times up the constant here with the power at x. Okay, times up, so you'll get 2 times 2 is 4, and then the power at the x here you need to subtract by 1, so it becomes, your answer will become 4x, right? 2 minus 1 is x power of 1, so x power of 1 is over here. It's similar to 4x. All right, so that is the formula on how to differentiate this. Now we proceed again or back to this, to our original question, by using the product rule. So y prime is equals to u v prime plus v u prime. Okay, so the u is, you just copy the u here, 4x squared plus 2, and the v prime is here, this is your v prime, so times 9x squared plus the v, the original one, is 3x cubed minus 1 times u prime is over here, 8x, right? So the rest is you just need to expand it. Okay, times up this, times up with the second term, right? So if we do one by one, so 9x squared times 4x squared, you will get, alright, 9 times 4 is 36x power of 4 plus 9 times 2 is 18x squared plus 8x plus 3x cubed, you'll get 24x power of 4 and minus 8x times minus 1 is minus 8x. So you try to rearrange this. Okay, so 36 plus 36 plus 24, you will get 64 plus 3 is 60 x power of 4. Okay, this one is done, plus 18x squared, okay, minus 8x. So this is basically missing the x, the variable x over there. Alright, if I check it, yeah. So just in case if you find any typo, or I probably calculate it wrongly, just let me know in my WhatsApp group, okay, so that everyone will notice the correction, and I may probably do the corrections on the description on the YouTube video, so that everyone will be alert. But so far this is right, yeah. Minus 1 times 8x is minus 8x. Okay, so we miss the x here. Alright, just need to do the correction on your module later on. Now we go to the quotient. quotient rule, similar to the product rule, we apply it for the product functions. So for quotient rule, we apply it when we encounter the function, okay, the function that has the ratio of two differentiable functions. So we can say that if we found fx equals to gx over hx, where g and the h function can be differentiated or differentiable, and the hx must not equals to 0, so that means we can apply the quotient rule. So we can write down like this. So y, so fx is y, so gx we assume as u, and hx is v. So in other words, we can write down y equals to u over v. So the formula will be y prime. So y prime is actually dy over dx, okay? So just use the short notation. So y prime equals to v u prime minus u v prime over v squared. So just a little reminder, okay, it is important that you do not swap this, okay. The function over here says v u prime, not u v prime. So you can't do this way. Y prime equals to u v prime minus v u prime over v squared. So this is wrong, okay. Unless you put negative in front and positive here, yes, this one is acceptable. But again, you cannot change the position. Oh, sorry, I want to pick this one, okay. You cannot change the position, okay, of the original formula. It is v u prime minus u v prime, okay. I hope that one is clear, okay. Don't change the formula to suit your okay. Now we go to some example. All right, so example 2.3. Okay, so we have this y equals to 7 minus 3x squared over 3 minus x. So if you notice, y equals to u over v, okay. So u over v, the u is a function which is 7 minus 3x squared. This can be differentiated, okay. You can differentiate it. V, meanwhile, v is 3 minus x. So you need to differentiate this function, okay, with respect to x. Okay, now let's do this one by one. So the solution for this is, first of all, you split it up. Okay, sorry, wrong copy. 7 minus 3x squared, and the v is 3 minus x. So we find the u prime, which is minus 6x. The v prime here is minus 1. Okay, so you just plug into the formula y prime. Okay, y prime is v u prime minus u v prime over v squared. So the v is 3 minus x, the u prime is minus 6x minus the u, okay, where's the u? Okay, u is over there, 7 minus 3x squared times the v prime is minus 1 over, don't forget we have over v squared, so v squared is 3 minus x power of 2. Now just need to expand it one by one, okay, expand it one by one. So you'll get here, okay, 3 times minus 6x is minus 18x, okay, minus x times minus 6x is plus 6x squared minus, okay, 7 times minus 7 times minus 1 is minus 7. Okay, this is negative minus negative times negative, we should get positive 3x squared, okay, over 3 minus x squared. So we just need to, okay, minus 18x plus 6x squared. Negative negative is positive 7, negative positive is negative 3x squared over 3 minus x squared. So yes, we can simplify this one. We have 6x squared minus 3x squared, so we'll get 3x squared, and then minus 18x plus 7 over 3 minus x squared. Yeah, okay. I hope that one is clear. So we can stop right there. Okay, no need to simplify it. Yeah, this is the final answer. Now we go to the okay, now let's proceed with the third technique, which is chain rule. So chain rule, when and how can we apply it? So to answer this, let's see what this text says. Right, so this rule or chain rule concerns functions that are expressed as compositions of functions. So it means that you can only apply the chain rule if that functions is a composite function. Alright, composite function. Now, what is composite function? Okay, so let's see what is composite function. So let's recap some quick review on composite functions. So a composite function, okay, we can call it as a composite function if the function can be written up as f(g(x). Right? So in other words, we can say that it is a function within a function or a function of a function. Well, this is a little bit in terms of the words and sentences, a little bit confused, but it's actually pretty simple. Alright, so this is an example. Okay, we look into an example. So if we have cos x squared, so cos x squared, we can say it as a composite function. Alright, why? Because if we write down it as fx, which is cos x, and gx is x squared, then we can have cos x squared equals to f(g(x). Okay, makes sense now? Alright, so f(g(x), again, f(g(x) is a composite function in the sense that there is a function, okay, let me change the color. There is a function within a function. Okay, makes sense now? So again, if we have cos x squared, okay, so we have this function x squared within the big function. So the big function or the outer function is cos x, the inner function is x squared. Right, so we can also call this one f(g(x), a composite function, as, okay, the gx we can call it as inner function, whereas the bigger one, the fx here or f(g(x), we can call it as an outer function. Right, okay. Now if we look into another example, so this is example 1. And this is example number 2. So for example number 2, if we have cos x times x squared, is this a composite function? Do you think this is a composite function? No, it is not a composite function. Okay, cos x times x squared is merely just a product functions, because we have two different functions, cos x as the first function and x squared as the second function. So this is just a product function. So if you want to find the differentiation for this function, for example, this is, we say, or we can write it as y equals to cos x times x squared. So no need to apply chain rule. Okay, we first need to identify, okay, this is actually a product function, so you can only apply, straight away apply a product rule to make or to find the derivative for this function. Okay, so again, if you find a function within a function or f gx, this is when you can apply the chain rule. Okay, so back to this. Okay, the definition of the chain rule. So the chain rule says the differentiation of the composite function f gx is equals to, alright, f prime gx times g prime x. Okay, now before we go into how to apply the chain rule, so we already know what is the composite functions, the difference between composite functions and the product functions. Okay, now let's see some example here. Problems. Okay, this problem 1 and problem 2 is to teach you or to train you to identify which one is a composite function, and also to identify if that function is not is a product function. Okay, so for example, in this problem 1, is gx equals to ln sin x is a composite function? If so, what are the inner and outer functions? So in your opinion, does this function is a composite function? Look carefully, does it has inner and outer functions? Now, you need to choose either one. Choose one answer. So first option, option A, G is composite. Okay, therefore the inner function is ln x and the outer function is sin x. B, G is composite, the inner function is sin x and the outer function is ln x. And option C, G is not a composite function. So in your opinion, which one is the correct answer? Is it A, or option B, or C? Alright, so if you answer C, G is not a composite function, it means that you are still not clear on how to identify a composite function, right? So C is not the correct one. If you answer A, for example, okay, so we know that G is now a composite function, but which one is the inner function, which one is the outer function? So if you write down this one, gx equals to ln sin x, I bet you can actually extract the inner, which one is the inner function and which one is the outer function. So if you look closely, the sin x and the ln sin x, so sin x is actually the inner function, whereas ln sin x is the outer function. Okay, so the correct answer is which one? The correct answer is B. Alright, so B is the correct answer. The inner function is sin x and the outer function is ln x. Okay, now let's see problem 2. Is hx equals to cos squared x is a composite function? If so, what are the inner and outer functions? So you need to choose one answer. A, h is composite, the inner function is cos x and the outer function is x squared. B, h is composite, the inner function is x squared and the outer function is cos x. Whereas C, h is not a composite function. Well, I bet you may answer h is not a composite function. Option C. Well, unfortunately, that one is wrong. This option is wrong. Okay, let me change the color of the red one. Okay, so if you answer C, it is not a composite function, then it is wrong. H is actually a composite function. So how is that? Now, which one you may want to pick as the right solution, whether A or B? So H is composite, the inner function is cos x and the outer function is x squared. B, H is composite, the inner function is x squared and the outer function is cos x. Well, which one is the correct one? Okay, if you answer B as your answer, then it is also wrong. The inner function is x squared and the outer function is cos x. Unfortunately, it's wrong. So the correct one is A. H is composite, the inner function is cos x and the outer function is x squared. So this is pretty much a confused one, but okay, let me show to you what does it mean by this answer. So we have hx equals to cos squared x. Okay, now if you assume that, okay, now we know that the composite function is actually f gx. So if you look closely, who is the gx, who is the fgx? So the gx is actually cos x, whereas the fgx is actually the cos squared x. Okay, or I might write it like this. So we can say that, or in other words, okay, let me change it. So, or in other words, if we put it as, okay, the inner function is cos x. Okay, let me define it as gx. Okay, now the fx, okay, the outer function, okay, the outer function is actually, if we change it to yeah, this is a better way. Okay, don't want to make you confused. So if we assume that u is cos x, right, u is cos x, which is, this is the inner function, then the x, I'm sorry, the y, the outer function is actually u squared x. This is the outer function. Okay, therefore we can say that the outer function, this is actually just a substitution. Okay, if you look it as a substitution, so if you substitute it back here, you'll get cos squared x. You got the idea now? Okay, so y is actually hx. Okay, you pretty get the simple, the same answer, not the simple, the same answer. Okay, just imagine it when you are using u substitution. So u equals to cos x, therefore y is equals to u squared. So if you plug in that, you'll get y equals to cos squared x. So basically the inner function is the cos x, the outer function is the u squared or the x squared. Alright, now we already know this one. So we also just now I mentioned that if you want to use the chain rule, you can use this formula, differentiate f(gx). Okay, when you differentiate f(gx), you'll get f prime gx times g prime x. Okay, now let's see some example from our module here. Okay, you see it's the same formula to differentiate the main function f, the capital F. So capital F prime, we will obtain f prime gx times g prime x. Okay, still not understand? Don't worry, we actually have another notation to do this. So this is another example, a simpler one. Dy over dx, it is actually dy over du times du over dx. So where does the dy and du comes from? So actually we can define it as y equals to fu, whereas u is gx. Okay, and therefore, okay, you can find the y prime or dy over du. As for the u prime is actually du over dx. Now if we look into this example, okay, example 2.4, okay, example 2.4, we have here y equals to x cubed minus 3 power of 2. You need to find the dy over dx or y prime. What is y prime? If you notice, I intentionally use dy over dx, or you can also use y prime. Either way, it's up to you. Yeah. So because it's still referring to the same concept or the same idea. Okay, now if you look closely into this question, you can abstract which one is the inner, which one is the outer. So for the inner function, we can say that u, okay, because u is the inner function, u equals to jx over here. Okay, u is equals to jx, so we can say that u in this question is x cubed minus 3, whereas the y, so y is fu, okay, it is actually u power of 2. Okay, you see, u power of 2. We have defined u as x cubed minus 3. I hope that one is much clearer to you. Once you identify which one is the inner, this one is inner and this one is outer function. Okay, now if you want to, okay, I'll show you if we are using this formula. Okay, so if you want to use this formula, so again I write down u is actually x cubed minus 3, y is u y is u squared, so u prime or du over dx is actually 3x squared, whereas this one dy over du is 2u 2u. Now we plug in into the formula, which is dy over dx equals to dy over du, we have dy over du times du over dx. So this is du over dx. So dy over du is 2u, du over dx is 3x squared. And the u here, okay, you need to plug in back the original function. So 2 times x cubed minus 3 times 3x squared. Okay, you can times up this one with the constant, so you'll get 3 times 2 is 6x squared. Alright, and 3x squared times x cubed minus 3, and this is possible to be simplified more if you if you want to not simplify, you want to expand more, so it will become 6x power 5 minus 18x squared. This is if you want to use the formula of the chain rule. Okay, this is the formula of chain rule. So you need to identify step by step. First you need to identify which one is the inner function and which one is the outer function. Okay, that is your first step. Your second step is you need to find the differentiation of each of that function. And the third step is you just plug in using the chain rule formula. Okay, another way to answer this is by using the original formula, which is y prime f prime gx times gx. Okay. Alright, so if you want to straight away apply the chain rule, once you already know which one is the inner and which one is the outer, you can actually straight away use this kind of solution. Okay, so we know that f prime is actually y prime here. This is y prime. So we know that this is it is basically the same thing. You need to identify which one is the inner and which one is the outer. So from this information, you can straight away plug in over here. So the outer function is f prime, which is u2. Alright, okay, so we can get here. Sorry, I don't know if you can listen to that, so just ignore the background noise. So f prime is actually this one is no f prime, this is still y. So if you want to find the f prime or y prime, it will become 2u. Okay, we already answered it here. Okay, 2u times this is g prime, yeah. Yep, g prime. So g prime over here is this one. It is 3x squared. So basically you just direct plug in. Okay, so 2u x cubed minus 3. This is 3x squared. Okay, and the solution is following the previous one here. Okay, 6x squared x cubed minus 3. So you can pick either one to choose, so long that it means that you still need to do step 1 and step 2. Step 1 and step 2. Okay, here the step 1 here and step 2 here. Alright, and then the only difference is that in step 3 I'm using this full formula here, which is more makes sense. Okay, because dy over du times du over dx, you can cancel out this one so that you initially get dy over dx. Okay, and or you can pick the third solution here, another formula which is actually the same one. Okay, which is this one, y prime equals to f prime jx times g prime x. Okay, alright, that is our chain rule. Right, so now we go to implicit. Okay, so we now go to the next technique, which is implicit differentiation. Okay, which is the fourth technique. How do I perform implicit differentiation? So in implicit differentiation, we can differentiate each side of an equation. Okay, so we have this kind of equation for an example. So we can differentiate each side of an equation with two variables. So we usually x and y by treating one of the variables as a function of the other. So this calls for using the chain rule. Okay, we already learned the chain rule, so let's now proceed with this example so that your understanding on this kind of technique is much better. Right, so we differentiate the x squared and y squared here, and also we differentiate on the other side of this equation, which is the 1. So if we differentiate the constant, we will get 0. And as for this, when you differentiate x squared, you can just straight away differentiate as usual, so you will get 2x. Okay, the special treatment, okay, special case for the y squared, because we are differentiating it with respect to x. Okay, we do this, you just treat it like you differentiate as x. So similarly, you'll get 2y, but you need the dy over dx. Okay, now notice that, okay, the derivative of y squared is 2y times dy dx, okay, and not simply dy, and not simply 2y. Right, I may explain it again. Notice that the derivative of y squared is 2y times dy dx and not simply 2y. Why? Okay, the reason is because we treat y as a function of x. Okay, so that we can differentiate it as usual. So we get 2y, but then we need to times out with dy over dx. This is a special case when you differentiate implicit differentiation involving variable y. Okay, now we go to the next step. So what happened is that we rearrange the terms so that the so that the 2x from here, okay, so we bring it to the other side, so it will become minus 2x. So what's left is that, because we're interested to get the dy over dx, so the final solution is that if you write it down, you'll get minus 2x divided by 2y. So you can cancel out the 2 here, so what's left is negative x over y. Okay, negative x over y. So if we go to our module here, we have a kind of a bit of complicated example. Okay, but it is interesting to do this example so that you can understand more on implicit differentiation. So you need to find the dy over dx if x squared y cubed minus xy equals to 10. So if you found this type of function, you know that you need to apply the implicit differentiation. Okay, so the solution is that we differentiate implicitly with respect to x. That is why we treat the x term here, okay, like we differentiate when we differentiate it with respect to x. Okay, so let me delete this one first. Okay, so the next step, the next solution is that, okay, maybe I can show you step by step here. X squared y cubed minus xy equals to 10. So we want to differentiate. If you look closely, we have a product of x and y here, x squared y cubed, and another product of xy. So we can write it down like this: d over dx for x squared y cubed minus d dx xy equals to d dx 10. So we know that the constant here, the derivative of it is 0. So we just need to focus on these two terms here, x squared y cubed and xy. So this is how you can do it. Okay, first of all, you need to dx x squared, right, y cube. Okay, it says it's stay over there, plus you differentiate the y. Okay, because this is the product or product function, you need to apply a product rule within the chain rule. So what happened in here is that it will become, okay, d, okay, this one is x squared d dx for y cube, okay, then minus d dx for x y, okay, plus, okay, x d dx y equals to 0. Now the next solution, okay, so we differentiate this one, okay, we will get, okay, we differentiate this one, we will get 2x y cube. Okay, if you notice, you are getting a similar answer here for this one. Okay, let me delete it. I don't want to make it confused. So this is 2xy cube plus, okay, and we try to solve this one, x squared. So we differentiate y cube, it will become 3y, okay, what happened? Okay, 3y squared dy dx. Remember I told you previously, when we differentiate the y term with respect to x, okay, you need to tag along or times up with dy dx. Alright, so minus, okay, minus, okay, so we differentiate x here, we'll get 1, okay, so we will get 1, so what's left is y, so okay, I will put a bracket minus, because this is the second variable, second function that we want to differentiate, plus, okay, x, so we differentiate this one, okay, this one we differentiate, we'll get 1, yeah, that is why we got y here, and then we differentiate the second term, it will become, we have x, we just write down x and only differentiate this one, it will become dy over dx equals to 0. Now if we can combine it, 3y squared dy over dx minus minus y minus x dy over dx equals to 0. Now we need to, up to this, we need to combine the term that has dy over dx into one side and without dy dx into another side. So we can write it down like this. Okay, so x squared 3y squared dy over dx. So we like combine or collect them together. So this is minus x dy over dx equals to, so the rest we bring it to the other side, this one over here and also this one going over there, so you will get okay, y minus 2xy cubed. Okay, once you get this, so we factorize it, dy over dx, factorize it, x squared 3y squared, okay, minus x equals to y minus 2x by cube. And then you can bring this part, okay, to here. So therefore it will become 2 dy dx equals to y minus 2xy cube over, so we have 3 as a constant, so we can put it in front here, 3x squared y squared minus x. Alright, so this is pretty much the solution for the implicit differentiation. Alright, so if you don't get it, the steps for this, you need to replay again. Okay, replay for this part and do it by yourself. This solution over here is already you know, they already simplified it. So if you want to learn it, this solution, try to study the one that I show it here. Alright, okay, so next we're going to look into parametric differentiation, which is the last step. As for the parametric differentiation, okay, which is the last technique, the fifth technique. Okay, this is when we need to differentiate a function that we assume we use t as another parameter. Okay, t as another parameter. So for example, if we have x equals to t squared, okay, and y equals to t cube, yeah, plus t. So what happened here? Okay, it has an equivalent of equivalent to the implicit function, which is y squared equals to x times x plus 1 squared. So how come this function is equivalent to this? Okay, that's the big question there. How come? So it is actually pretty easy. So we have here, okay, we have here y. Let me show it to you. So I have here y equals to t cubed plus t, and I have x equals to t squared. Okay, now if I want to substitute the x into here, I need to if I want to substitute the t here with x here, so the x over here I need to, okay, so t will become x, square root x. So just plug in the t equals to square root x into here, into this function y. So what will happen is that therefore y is equals to, so t cubed, so we have here, okay, you can actually before that you can actually factorize it first. So t equals to t squared plus 1. Okay, we factorize it so that the substitution of t equals to square root x can be done much easier. So t is actually square root x, and times up t squared is, okay, we have x square root squared plus 1, and then we will have here square root x. This will become x plus 1. So the square root of x squared is cancelled out, so what's left is x plus 1. And to remove the square root x here, okay, we just need to times up to cancel out this one, yeah. So we put squared here, so that's this one squared, so y squared will become x plus 1 square root. So basically I have proved it is equivalent with this one. Okay, now how can we differentiate when we have this kind of function? Okay, so if this equation of the curve is defined by y equals to t cubed plus t and x equals to t squared, so if we find the dy over dt for this one and dx over dt, we will get this one. Therefore, when we want to obtain the dy over dx, okay, you actually need to rearrange it from this dy over dt times dt over dx. It means that you just need to change the dx over dt over here to become dt over dx. It means that when you swap it like that, you just change it to become 1 over 2t. Okay, so this is pretty much like we want to cancel out the dt over here, so that is why we can get on the right side here dy over dx, so that it will fulfill the definition of dy over dx on the left side. Okay, if you're still confused, let me see if we can let's see this example 2.6. So let's say a curve that has parametric equations, which is x equals to t minus 3 over t and y equals to t squared plus 4 over t. So you need to find dy over dx. And so in order to do that, again, you need to find the dx over dt. Okay, you need to know that the formula for parametric is dy over dx equals to dy over dt times dt over dx. So this is the formula, okay, for the parametric differentiation. Okay, now you already have the x function and y function, so if you differentiate this, you will get dx over dt, and if you differentiate y, you will get dy over dt. The only step that you need to, when you're done finding the dx over dt and dy over dt, don't forget on dx over dt to change it to be dt over dx. This is the crucial step that you need to do. So whatever things that you've got this, you need to swap it the position, okay, so that you only then you can plug in the value here, right, into this. Now back to this original question, we have x equals to t minus 3 over t. So here you can simplify it to become 1 minus 3t power of minus 1, and therefore we can get the dx over dt to become 3t power of minus 2. Okay, or in other words, you can write down as 3 over t squared. Therefore, if we want to find the dt over dx, so that we can use this formula here, we can plug into the formula, so you get t squared over 3. And then for the y here, again you can simplify it. Let me delete it, this one, so that we can see it clearly. So as for the second part here, we simplify it, so it becomes t plus 4t power of minus 1. So the dy over dt is 1 minus 4t power of minus 2. And then by using the chain rule, this is the chain rule definition, we already changed it to this one for the dt over dx, so just plug in over here. And for the dy over dt, just plug in over here, and you will get the final solution as this. Okay, now to see whether you are okay or thoroughly understand with all these examples under techniques of differentiation that we just discussed here, try to do exercise 2.2. Okay, exercise 2.2, try to do question number 1 until question number 5 and 6. So yeah, 6 questions altogether. Try to do it at home, and you can refer or check your answer later on. I will give you the QR code for the answers for chapter 2 here. Alright, till then, until next week, we will proceed with the next subchapter, differentiation of the trigonometric, hyperbolic, and logarithmic. Alright.